Section 5.2, properties of definite integrals. For constants a, b, c, little m, and capital M, integral from a to b of a constant c with respect to x is just that constant times the b minus a, the difference of limits. The integral of a constant times a function is the constant times the integral. Integral from a to a of f of x is 0. Integral from a to b f of x is the opposite of the integral from b to a of f of x. Integral from a to b of a sum is the sum of the integrals. Integral of the difference is the difference of the integrals. Integral from a to c plus the integral from c to b is the integral from a to b. If x is greater than or equal to 0, then the integral is going to be greater than or equal to 0. If x is greater than or equal to g, then the integral of f is greater than or equal to the integral of g. If f is bounded by little m and capital M, then the integral is going to be between the two bounds times the length of the interval. If f is odd function, the integral from minus a to a is equal to 0. If f is an even function, then integral from minus a to a is equal to twice the integral from 0 to a. So those are some properties. They're fairly straightforward to prove. They more or less follow from the definition of the integral. Okay. So there's also a mean value theorem for integrals. Before we went over, when they talk about the mean value theorem, usually they're talking about the mean value theorem for derivatives, but there's also one for integrals, and it's related to the average value of a function on an interval. If a function f is continuous on an interval from a to b, and then there's at least one point c in the interval of a to b such that f of c is equal to the average value of the function there, 1 over b minus a times the integral from a to b of f of x dx. Okay. So example, the height of a rocket from time t equals 0 to the time the fuel runs out. Actually, time 0 is which is when the fuel runs out, up to the time t equals 3, which is when the rocket hits the ground, is h of t equal minus 16t squared plus 32t plus 48. So let's compute that integral and also the average value. So the integral is going to be we want the integral of I'll do the integral separately first, and then I'll compute the average value. So we want the integral of h of t dt over the interval from 0 to 3, and that's going to be the limit as n goes to infinity of the summation of k equal 1 to n of h of 0 plus 3k over n times 3 over n. Okay, that's by the definition of the so the interval length is from 0 to 3. The interval length is 3, so that's the entire interval. So when we divide it into n intervals of equal length, each interval width is going to be 3 over n. Okay, so then we can so we're starting from 0, so our left endpoint is 0, so 0 plus anything is 0. So this is the limit n goes to infinity of summation k equal 1 to n of h of 3k over n times 3 over n. Okay, so then so we want to put this 3k over n into the formula for the height of the rocket, so we replace t by 3k over n. So this was the limit. N goes to infinity, summation k equal 1 to n. And it's going to be minus 16 3k over n squared, 3k over n quantity squared, plus 32 times 3k over n, plus 48. I'm running out of room here. And then the whole thing times 3 over n. Okay. And I'll get another page here. Okay, so I'll put this up. Okay, so this is going to be if we distribute the exponent, we'll have 3 squared is 9, 9 times 16 is negative 144, so we'll have the limit as n goes to infinity, summation k equal 1 to n of negative 144 k squared over n squared. 32 times 3 is 96, plus 96k over n, plus 48, and the whole thing is times 3 over n. And then we can distribute the 3 over n. Distribute that. So this is will have be the limit. N goes to infinity. K equal 1 to n of it's going to be negative 432 k squared over n cubed plus 288 k over n squared plus 144 over n. Okay, so we can split up the limit, split up the sum. This is going to be the limit as n goes to infinity. The minus 432 over n cubed can be factored out, so we'll have minus 432 over n cubed summation k equal 1 to n of k squared. Plus the limit as n goes to infinity of 288 over n squared, summation k equal 1 to n of k, plus the limit n goes to infinity of 144 over n times summation k equal 1 to n of 1. Okay, so then we can use our shortcut formulas. This summation k equal 1 to n of k squared, the shortcut formula for that is n plus 1 times 2n plus 1 over 6. So this will be, we'll have the limit as n goes to infinity, minus 432 over n cubed, and we'll have n plus 1 times 2n plus 1 over 6, plus limit n goes to infinity, 288 over n squared, and this we have the summation k equal 1 to n of k. The shortcut formula there is n times n plus 1 over 2, and this last sum is 1 plus 1 plus 1 n times, so it's just going to be n we'll have plus, okay, plus the limit, n goes to infinity of 144 over n times n. Okay, so these n's will cancel, and 16 to negative 14432 is negative 72. So this will be am I missing something here? I think I'm missing something here. There should be another n here. This shortcut formula should have another n. So one of the n's will cancel here. Okay, so we'll have the limit, and it goes to infinity of minus 72. One of the n's cancels. We can write n plus 1 over n, 2n plus 1 over n. One of the n's will cancel here. 2 into 288 goes to 144. So I have plus the limit, n goes to infinity, 144 times n plus 1 over n. The limit of a constant is just that number, that constant, so that's plus 144. Okay, so we can rewrite this as limit n goes to infinity of minus 72. If we distribute the denominator here, we get 1 plus 1 over n. Distribute the denominator there, 2 plus 1 over n. Plus the limit, n goes to infinity, 144 times 1 plus 1 over n plus 144. Okay, so now if we take the limit, we'll get now we take the limit, we get minus 72 times 1 plus 0 times 2 plus 0 plus 144 times 1 plus 0 plus 144. So that's going to be, we'll get negative 144 plus 144 plus 144, and that's equal to 144. Yeah, 2 of these will cancel. That just leaves us with 144. So the integral is going to then be 144. And that means that the average is going to be, we have over a 3-second period. So the average height is 144 divided by 3, because it's over a 3-second period. It'd be 48 feet is the average. Okay, so okay, so okay, so we want to solve. We want to find some number c that is equal to the average. We need a number c such that f of c is equal to average. So we want to solve h of c. So we have h of c is equal to 48. So that means that h of t is going to be, so it's going to be minus 16 c squared plus 32c plus 48 equals 48. And we're going to solve that for C. So the 48 and the 48s will cancel, and so we'll just have minus 16c squared plus 32c equals 0. We can factor out the minus 16c, and that will give us minus 16c times c minus 2 equals 0, and use the zero product rule that minus 16c equals 0 or c minus 2 equals 0, and divide by minus 16, add 2 to both sides, we get c equals 0 or c equals 2 seconds. Okay, so we get there's the mean value theorem for integrals guarantees there's some time when the height is equal to the average height of that rocket, equal to the average height of the rocket. In this case, we we actually had the average value at time 0, but there's also at least one point. We got one additional point at time 2 seconds where the height of the rocket was equal to the average height. Okay, so if we just by way of contrast, let's also apply the mean value theorem for derivatives here. So if we go back to this example here, instead of average height, we'll compute the average velocity of the rocket. So the average velocity is going to be h of 3 minus h of 0 over 3 minus 0. So that's the slope of the secant line. So the height of the rocket at time 3 is, that's when it hits the ground, is 0. The height at time 0, if we plug in a 0 here, we get 0 plus 0 plus 48 is 48. Over 3 minus 0 is 3, so this is minus 16 feet per second would be the average velocity. So the mean value theorem for derivatives guarantees that there's some time in the interval such that the average velocity is equal to the instantaneous velocity. So the average, the velocity, the instantaneous velocity is going to be v of t is derivative of the height, which would be minus 32t plus 32, and there's some time where that should be equal to negative 16. So if we solve for t, subtract 32 from both sides, we get minus 32t is equal to negative 48, and then divide, we get t is equal to about 1.5 seconds. So the after 1.5 seconds, the slope of the tangent line is parallel to the slope of the secant line over that time interval. Okay, so anyway, that concludes this presentation. Okay.